Now coming to the third law. The third law was actually discovered by Nernst. There are two ways in which it can be stated. One, as temperature tends to absolute zero, the entropy S also tends to zero. Or there is another way also. One can go arbitrarily close to the absolute zero of the temperature, but it is impossible to attain absolute zero in finite number of steps, or it is just impossible to achieve zero Kelvin. That is what Nernst put forward. And this has a direct implication to entropy, since it was further modified by Ludwig Boltzmann. Ludwig Boltzmann proposed the statistical definition for entropy in 1870s. Boltzmann went on to show that the definition of entropy was equivalent to thermodynamic entropy within a constant number, which is known as Boltzmann constant. And another thing I can say is that thermodynamic entropy is a non-conserved state function. You cannot say it is conserved. But it is of great importance in science of physics and chemistry. In statistical mechanics, how entropy is defined is, entropy is the measure of number of ways in which the system can be arranged. Boltzmann derived an equation S is equal to K log omega, where omega is thermodynamic property. And he also said that entropy is the only quantity in physical science that seems to imply a particular direction for time, and hence it is sometimes called as arrow of time. Even such big contribution was made by Boltzmann. Boltzmann's life ended in a tragedy. Practically single-handed, he developed the kinetic theory of gases, which I am going to discuss in class. Some of the contemporaries who lived in Boltzmann's era didn't believe in his theory, attacked him viciously. Unable to bear the hurt, Boltzmann committed suicide by jumping into Adriatic Sea, very near to International Center for Theoretical Physics founded by Abdul Salam. But this equation is very popular, that is why it is been engraved in Boltzmann's grave. You can see that in the photo. It's engraved. S is equal to K log W. Now there are many approaches to understand entropy. Some say entropy can be defined as order. Some say entropy can be defined as disorder. Or we can say it is an approach to attain uniform temperature throughout. Or we can say that it is the degree of energy dispersal in the universe is defined by thermodynamic variable entropy. Anyway, this entropy is being widely used in different branch of science. In some branch of science, we talk about neg entropy. It is a shorthand colloquial phrase for negative entropy. Some call it as extropy, a metaphorical term defining the extent of life, organizational system intelligence, functional order, vitality, energy life, experience, capacity, drive for improvement. Some talk about ecological entropy, a measure of biodiversity in the study of biological ecology. And in cosmology, black holes are said to have maximum possible entropy, and this makes them likely to be the end point of all entropy increasing process. And another concept is entropy gap. Entropy gap means right now in the present, the universe is at a particular entropy. And the Big Bang which caused the universe may result in a big crunch in a later time. So at the big crunch, there will be an entropy, which is a predicted entropy, which is the maximum entropy available. So the gap between the entropy at the present and the entropy at the big crunch, that difference is called entropy gap. And it has also many philosophical applications. Now let me share some interesting facts as a conclusion to my lecture. It's a talk between Claude Shannon and Newman where they were talking about some application in phone line signal transmissions. They were talking about how to measure the uncertainty in signal transmissions in phone lines. Here we can see that Claude Shannon and John Wayman's discussion. My greatest concern was what to call it. I thought of calling it information, but the word was overly used, so I decided to call it uncertainty. When I discussed with John Wayman, he had a better idea. John Wayman told me that you should call it entropy for two reasons. In the first place, your uncertainty function has been used in statistical mechanics under the same name, so already it has a name. In second place, and more important, nobody knows what entropy really is. So in a divide, you can always have an advantage. So entropy is, that is why it is called a ghostly quantity. So there are many possibilities to think about the concepts of entropy, the meaning of entropy, the philosophical implications of entropy. All this can happen only if we function in an openly manner. As Sir James Dewar says, minds are like parachutes. They only function when they are open. Thank you.